Hello everyone, welcome back to your channel Physics with Oliva. Today we will discuss another problem. Before starting the problem, I will request you to subscribe the channel and press the bell icon. Let's start. At first read the problem. A particle of mass m is projected with a velocity v is equals to kve from the surface of the earth. The maximum height above the surface reached by the particle is. So VE is the escape velocity. We should know the formula of the escape velocity. The formula of the escape velocity is root over 2g capital R, or we can write it 2gm by capital R, where small g is the acceleration due to gravity, capital G is the universal constant, capital M is the mass of the earth, capital R is the radius of the earth. Okay, now it is given the velocity is kve. Suppose this is the surface of the earth and we are throwing a particle from here. When we are just throwing the particle, then the particle is on the surface of the earth. From the center, the distance is capital R. This is the earth. Okay. So here the potential energy is minus gmm by capital R, where small m is the mass of the particle which we are throwing, right? And now the kinetic energy is half mv square, and the value of the v is given here, which is kve. Okay, so this is the total energy of the particle when we are just throwing the particle, and this is the maximum height where the particle is reached. Maximum height means at this position the velocity of the particle becomes 0 and the particle can't go above now because the velocity becomes 0. So how can the particle will go above? Now from this position the particle will return. Okay, this is the maximum height, h max. Okay, so here the kinetic energy is equals to half m into the velocity square, but at the maximum position the velocity is 0, so the kinetic energy will be 0, and the potential energy is equals to minus gmm divided by the distance. The total distance is this r plus h max, r plus h max, right? So this is the total energy at this position. Suppose this is position A, this is position B. At position A, this is the total energy. At position B, this is the total energy. According to the conservation of energy, this total energy at position A should be equals to the total energy at position B, right? Right, this is the total energy at position A and this is the total energy at position B. Now we will solve this. Gmm by R, we will put the value of VE here. This is k square and VE square means 2gm by R, right? This is VE square and this is minus gmm by R plus h, right? This 2 and 2 will cancel out. From here we will get m, capital M, g divided by R, here k square minus gmm by R. This is minus gmm by R plus h. This all will cancel out. So from here we will get, if we take common 1 by R, we will get k square minus 1 equals to minus 1 by R plus h, right? So from here we can write 1 minus k square is equals to R divided by R plus h. Now we can write R plus h divided by R is equals to 1 by 1 minus k square. Then R by R plus h by R is equals to 1 by 1 minus k square, and then we can write 1 plus h by r equals to 1 divided by 1 minus k square. So this h by r is equals to 1 by 1 minus k square minus 1. So h is equals to 1 k square, 1 minus 1 plus k square into r. So h is equals to 1 cancel out. H is equals to k square divided by 1 minus k square into r. This is the maximum height. So from the option we are getting option 4 is the right. K square r divided by 1 minus k square. So option 4 is the right answer. Thank you everyone for watching the video. Please like, share and subscribe the channel.